Hey everyone, Adam the Tutor here, coming at you with another Laplace Transform. This time we're doing f of t is equal to cosine of omega t, right? And for this one, what we're going to be using is that cosine omega t is equal to 1 half e to the I omega t plus e to the minus I omega t, right? So basically, it's going to be the same process, so let's just go ahead and get started here. So we're going to have that the Laplace transform of cosine omega t is going to be equal to the integral from t is equal to 0 to t goes off to infinity of 1 half e to the I omega t plus e to the minus I omega t, and then we're going to have e to the minus st dt, right? And that's going to be equal to 1 half integral from t is equal to 0 to t goes to infinity of e to the I omega minus s times t plus e to the minus quantity I omega plus s times t dt. So now when we integrate this, we'll have 1 half, and we'll have I omega minus s, and we'll have our exponential again, and we'll have a plus, but because, well, actually we won't have a plus. Here we'll have a minus, right? Because what's going to happen is that when this guy comes down in the denominator, we'll have that minus there, right? So we'll have e to the minus I omega plus s times t, and we'll have I omega plus s, right? And again, we're going to evaluate this from t equals 0 to t goes off to infinity. Well, again, like I said in the first video, right? When t goes to infinity, basically this whole first term will be 0. So right, this whole first term is this guy evaluated as t goes to infinity, right? So that's easy enough. But then when we plug in t is equal to 0, both of these exponentials, this guy and this guy, are both 1, right? So then we have 1 I omega minus s minus 1 over I omega plus s, right? And again, we'll have our common denominator is going to be I omega minus s times I omega plus s, and that's just going to be equal to negative omega squared plus s squared, right? So we're going to get a negative 1 half, and we'll have omega squared plus s squared. This is going to be I omega plus s, and then we're going to have minus I omega minus s, right? So basically this time the I omegas cancel out, and we get 2s over omega squared plus s squared times 1 half, right? But the 1 half will cancel out with the 2, and so we'll just have s squared is equal to omega squared plus s squared, right? And that's basically our answer. So we have the Laplace transform of cosine omega t is equal to s squared over s squared plus omega squared. And that should not be s squared. That should just be an s to the first power. Got carried away with the squares there. So this right here is our final answer, right? So again, not too bad. It's the same process as the evaluation of sine omega t. Use Euler's formula, break it in, you integrate these exponentials, come down here, find this common denominator, but instead of an omega, you get an s, right? So that is basically going to do it for this video, and if you have any questions or comments or anything like that, just drop them in the comment section below, and I will do my best to address those. And I'd like to thank you for watching, and I will see you in the next video.